Good evening, Nano fam. Been a while since the last stream. Welcome, everybody. Let's see, Andefnal, nice to see you again. So, howdy, how are you guys? How does Nano bootstrap? That is the topic for this stream. And I have just opened up my notes here. I'm a bit unprepared because the dev meeting went so long, and I haven't streamed in a while, so I probably forgot some things to set up correctly. All right, here we are. Here are my notes. So I spent some time last year to fix the raffle app, and let me see if that works. So yeah. Now we have Twitch implementation and a functioning YouTube implementation. So if you guys send your Nano address in chat, it should automatically put you on the spinner. But I have to reload the spinner here in OBS, I see. Hey, Katrin! Let's reload that one quickly. Where is it? Spinner? Now, how does that work? Can I reload it? Here, refresh cache. I think. Yeah, no, spinner offline. Oh, maybe maybe the IP address has changed. What's my IP address? Sorry for the delay, but I'm a bit. I haven't streamed in a while, so let me just check my IP. So what is the IP here? What's my IP here? .2.55. Yeah, that's the wrong IP. Wrong keyboard. 55. Is that right? 2.255. 2.255. What? No. Okay, sorry for the delay. Should work any moment. And what does the spinner say? Online. See, guys, that's what I was looking for. Online. So that means the spinner should work. So let's start it right now. So I got so many donations when I announced that the Rust node was fully ported that I wanted to give some back to you guys. And that's why we are giving away 30 nanos today. So 1 nano every 4 minutes, I think, is the countdown. So quickly, guys, just post your nano address in chat so that you are on the wheel. The first giveaway starts in 200 seconds. So Andefnal, yeah, see, it worked. See, there is your message, and there you are on the participants list. Great. I love automation. That was so annoying in my past streams when I had to put all of you on the spinner by hand. And cheers to the Nano fam. Water, of course, water. No beer in there. So, Andefnal, yeah, copy paste and stuff. Yeah, so this spinner wheel app is open source, and if you want to write your own Nano based tool, you can use this as an inspiration and copy paste code from there. And it even does the proof of work generation with the GPU now. So hopefully, Mads, you are registered. Welcome. And yeah, that's cool. See, now all of the nano addresses keep coming in, and I don't have to do anything. Isn't that cool? Spinner's really cool, says it's birthday boy. Yeah, thanks. That's cool. Bram, okay, so you can see if your name is in the participants list, it worked. And I think it worked from Twitch and from YouTube. Okay, so let me just check my notes. Yeah, so the new raffle bot works, and it is on GitHub, and it uses the GPU proof of work now. Oh, and I extracted a Rust library, a crate. Rust calls them crates. I extracted a Rust crate for proof of work generation from Nano that you can reuse now. So I updated the diagram already. So these are the RsNano crates we have, and RsNano work, this one is new. And yeah, it's super easy to use. You can just put it into your own project, and then you can create the work for your nano code. So that was that. Okay, and as you've heard in the dev meeting already, we are very close to the very first RsNano release. I successfully bootstrapped the beta node, and it's still running. So that is on beta.rsnano.com. And as you can see, it is fully synced, and it even is voting. It has 3 million beta nano vote weight. So yeah, that's exciting. So the first release of RsNano 1.0 is very, very close. So let me see what you guys write in chat. Nano Rust Time says 1401. Welcome 1401. It's Birthday Boy says, is it code from Nano Work Server? Yeah. So I copy pasted the OpenCL code from the Nano Work Server and integrated it into RsNano, and it works like a charm. So hey, 1401, you just won the first Nano. Congratulations. Matt says, awesome, might be able to use that for sub Nano. Oh, that's cool. So if you need any help or have any suggestions, just let me know. And in the spinner wheel, I added a delay. So because Nano is so fast, you would get the Nano before you would see who won. So I added a 15-second delay for sending out the Nano. Let me know if this delay works well, because you shouldn't receive the Nano before you see who won. 1401, insane technology. Thanks, good stuff. Mark Sarna says, can I join? Yeah, just post your Nano address in chat. That's all you need to do. Okay, guys. So the beta node running. If you have some time and feel adventurous, try it out. Run a beta node and let me know how it works. And yeah, and go to the Discord, our RsNano Discord, and that's the best place to discuss how it's going. Bram says, amazing. All right, so let me hide this thing here. Okay. Okay, so 30 nano giveaway today. 30 nanos. And next stream too. Yeah, so there was something I wanted to ask you. A new concept for the stream that I want to try. Have you guys heard about mob programming? It is like pair programming, but on steroids. So you don't just work in pairs, but you work as a group. And I have never tried mob programming, so like 3 or 4 or 5 people who work on the code at the same time. I always wanted to try that. And today I thought, I have so many devs in the stream, and maybe you wanna help with Nano, and maybe you don't know Rust and feel that's what's keeping you from helping, or maybe you just want to spend some fun time with me programming. I want to try mob programming on the stream with you guys. So maybe 2, 3, 4 of you can join with your webcam or just with your audio if you like, and we try mob programming on the code, where we switch between one who types. This one is called the driver, and the other of the team, they tell the driver what to type, and those roles switch quickly. So you are a driver for maybe, I don't know, 5 minutes or 10 minutes, and then the next one is the driver, and we could work on the code together. What do you guys think? Would you join in a mob programming session? Andevnal says yes. I never heard about anyone who did it. I like ever. Yeah, I also have never done it, but I read a lot of good stuff about it from teams who tried it, and I think RsNano is a big code base and maybe scary to get into, and maybe a mob session on stream would be a good place to get started. Mark Sarno, you won 1 nano. Congratulations. So yeah, so if you guys want to try that, I want to do that next stream, maybe next Tuesday even. Could be fun. I want to do this as an experiment, and if it's cool, why not code together on stream? We could call it like let's we code or code together. It's Birthday Boy says not knowing Rust is the major issue. Yeah, but this could be a good opportunity to learn Rust. It's Birthday Boy says, but it's a good idea. And Defnal says, yeah, it's Birthday Boy. Yeah, why not? Like, you don't have to know Rust. We can use this as a Rust learning session then even. I want to try that. Okay, so that was the mob. Yeah, that was the mob programming idea. And yeah, so the topic for today is how does Nano bootstrap? And I am still in the process of learning that, so I'm not saying that I have all the answers, but I spent quite a bit of time refactoring the bootstrap code, splitting it up and adding unit tests. And yeah, so my goal is to get the unit test coverage way up. I have this code carve integration now on GitHub, where every commit automatically creates this coverage report, and we are currently at 68%, which is pretty low. But this is just the 68% from the unit tests. So we have two types of tests in RsNano. We have the unit tests, and then we have the what I call integration tests, and those are the tests that run a full node. And we have a lot of those integration tests, and they cover a lot of code, but they are not in this report because I want to focus on the unit tests alone. So right now we have a 68% test coverage just by the unit tests. And the programming part for today will be getting this number up for the bootstrap code. Pretty cool this side. Yeah, you can just click through the code, and when you open up a file, you can see what's tested and what's not tested, and or line covered. So all the covered lines are in green, and all the uncovered lines are in red. And that by itself, of course, shouldn't be the goal. But it's a good indication of where tests are missing. Yeah, so that's what I want to do in the programming part today. But before we start coding, let's talk about how Bootstrap works, or my current understanding of how Bootstrap works. Yeah, where to start? I drew this diagram, I think a week ago or two, so I have to get started myself now. so maybe we start with the bootstrap code, where you find it. So I put all of the bootstrap code into the folder. Let's go back to GitHub. Put all of the bootstrap code into node source bootstrap, and this code looks quite a bit different from the C++ code, because I split the C++ code up into many more classes, and so that I could test them easier. It's Birthday Boy says, I'm actually looking forward to RsNano a lot. I have started working on a new RPC proxy, but written in Rust, since the current Johansson one is in JavaScript TypeScript. So there is a performance limitation compared to the underlying C++ node, nano node itself that it is proxying. Will be nice to have both the Rust proxy and RsNano nano node. Yeah, that's cool. So, and you can even reuse maybe a bit of code from RsNano, because let's open up the crate diagram again. These are the current crates, and I've planned to extract many more crates so that you guys can reuse them in your tools. And when you look at RPC, we already have a crate called RPC messages, nano. So all of these crates start with nano, RsNano underscore. So we have a crate called RsNano RPC messages, and let's just have a look at it. RPC messages. So you could reuse this crate, and it contains all the RPC messages, and that could be something. Don't know if you need it, but if you want to create a tool that uses nano RPC, you can just use that. Same for, I think I even have a crate for an RPC client. So that is, that just makes working with nano just easier. You can just reuse the RsNano crates, and those RPC client crates and messages crates, of course, they work with the C++ node too. They are compatible. Raptor says, looks complicated. Oh, it will look a lot more complicated the more crates I extract. And if not, congrats to me. Oh, did you win? I didn't see the wheel. It's Birthday Boy says, that's actually really helpful. Awesome, cool. Yeah, so same thing for WebSockets. So there's a crate with the WebSocket messages, and in the future, one day in the future, I will also add a crate with a WebSocket client, so that you can just very easily connect to the nano WebSocket. And this is the work one that I showed you earlier, where you can just create blocks and create your proof of work on your machine, like my ReflBot does. Okay, but back to Bootstrap. So node source Bootstrap. So I split all of the Bootstrap into 3 parts: requesters, response processors, and state. Congrats 1401 for winning 1 nano. So it works like this. There are a bunch of requesters, and that are classes that... Where are we? Let's see. Do we have them here in the diagram? Yeah. So here we are. We have requesters. And there are 3 requesters, and they send different types of requests to other nodes in the network. And as Nano's communication is asynchronous, That means we just send out the requests, and at some later point in time, we might get a response back. It's not guaranteed that we get a response back. We just might get a response back. So the requesters are the ones that send out the requests. And once we get a response back, they are handled by the response processor. And just as there are 3 types of requesters, there are 3 types of response processors. And they just handle the messages, and we will have a look at what they do exactly soon. And you can find this structure in GitHub too. So we have a folder called requesters. We have a folder called response processors. And we have a folder called state. And what state contains are these green boxes. They contain the state. I tried to separate state and infrastructure. Again, infrastructure for me is code that talks to the outside world, like the network, like the disk. So the state is just data or data. Data or data? What do you guys say? So the state is just data, and the requesters and the response processors, they are the ones talking to the database and to the network. And that helped me with unit testing the state, because all of the main logic is in the state part, and that doesn't use infrastructure, so it's easy to write tests for that. So, oh, 1401, did you win again? Nardo ETH, good to have you back, Gustav. Thank you, Nardo ETH. And Northfall says, option, how can Nano claim to be a digital currency when it doesn't offer privacy? More like a proof of concept. Ooh, it would be cool if Nano had a privacy. And I thought a lot about that topic, but I haven't found a good way to bring privacy into Nano and to keep up the instant and feeless part, really. So Nano is designed to be eco-friendly, instant and feeless, and the whole protocol is focused on that one. And how would you bring privacy into it without destroying Nano's properties? If you have a good idea, let me know. I'm a privacy fan, and yeah, but that is just, it's not simple at all. And there was a couple of ideas, and none of them I found good. Cure asks, what does the wheel do? Oh, it's the Nano giveaway. So we give away 1 Nano every 4 minutes. If you want to take part, just post your Nano address here in chat. 14.1 says, in my opinion, pseudo-anonymity and mixers is a good compromise. Yeah, it is a good compromise. Although it would be like, if Nano had like a full-blown privacy, it would be, yeah, unstoppable. It would be unstoppable. Gustav, does the tool work? I didn't receive it. Or is it just me, guys? Oh, does the tool work? Let me check the logs. Let me check the logs. No, it... Oh, I forgot something. Oh, sorry, guys. I forgot to enable my Nano node. Ah, man. Ah, no. I'm sorry, guys. I forgot something. That. Ah, no. How many winners didn't get their Nano now? Let's see, winners. You know what? I'm sending it you manually quickly because I have the list of winners here. So that is do I see your nano address? I don't see your nano address. So 1401 has two nanos. So didn't want to do this stuff manually, but now I have to do it manually again. So let's send 1401 2 nanos. Where's 1401's address? Now I have to find it. Here it is. 2 nanos. What else was it? RsNano 2 nanos. Where's RsNano's address? RsNano here. 2. And of null 1 nano. Oh. Okay, so the next spin should work now. Oh, there it is. Let's see if it works. Mads U1 1 nano. And these are the logs. Let's check the logs. Price sent. So now it worked. Sorry. Oh, I'm so sorry. I forgot to connect the raffle bot with my node. Okay. So, what does the chat say? It's Birthday Boy says, I think not having privacy might be better, since for it to be adopted, governments will be more on board if it's not private. That's true. That's a good point. And Z-Nano, Zcash tag plus nano, very feasible. Yeah, no, it's not really combinable. 41 says, although I would love Monero privacy, I think realistically governments worldwide would make that illegal very quickly. Tax evasion and crime, yeah. To be honest, I'm surprised we haven't seen that with Monero yet. But a lot of exchanges are delisting it. Yeah, especially for me, I'm from Germany, and there's many cryptos that you can't trade in Germany anymore. Underflow says, Monero is too private for regulators. Cropter, it's not a Gustav stream without spinning wheel problem. Yeah, we will get it fixed. It will work one day. And 41 says received. Okay. Okay. And Norfell says money functions effectively because of fungibility, ensuring each unit is interchangeable and indistinguishable from another. Coin's history. Coin's history. Well, I think Nano is not as acceptable as Bitcoin for this because we don't have a UTXO model, we just have an account model, so we don't track individual coins. So you couldn't, in the same way, say a coin's history because you don't have that. Crypto says, will new German government be more crypto-friendly? I have no idea. And Norfell says, but Europe is defending users' privacy. Are they? So, okay. So where did we stop? bootstrapping. Yeah, requesters, response processors, and state. Where's the diagram here? So, yeah. So, as you can see, there are 3 types of requesters and 3 types of response processors. So let's look at these 3 different types. And let's start with the most important one. And that is the priority requesters and the priority response processors. And how this functions is we have a list of accounts that are candidates for bootstrapping. So these are accounts where the node knows that we need to bootstrap them. But of course, when Bootstrap starts, those are millions of accounts that are candidates. So we have to prioritize them. And that's what the struct candidate accounts does. And this is called differently in the C++ node. There it is called account sets. I found the name account sets to be too generic, so I called it candidate accounts. And it is just a collection of accounts plus a priority for that account. And what you can do there is you can increase or decrease an account's priority. Whenever we process blocks, we either increase or decrease an account's priority. And the priority requester is a thread that just says, give me the next priority account, and it receives an account, and then it creates a request for that account, a priority request. That means it asks another node in the network. It says, hey, I have this account, and I'm at block block ABC. Give me all blocks that are newer, or give me the next 5 blocks for that account. So, for example, give me the next 5 blocks for this account. This is what the priority requester does. This runs in a loop, in a background thread, and yeah, just sending out the priority requests. Fortune1 says, is the wheel broken again? Did it work now? No, I think it worked. Checking the logs. Yeah, I think everything is okay. Let me know if you don't get the nano. And this is the heart of the bootstrapping of Nano, because all the other requesters and processors are just here to support this main priority requester. So, and as I said, this is asynchronous. So the first step is to create a priority request, send that out, and at some later point, we might receive a response. This is here called the blocks ACK, so the acknowledgement. So this is a message with the blocks. We said, hey, other node, give me the next 5 blocks for this account. And the other node responded and said, look here, these are the next 5 blocks for this account. And this message goes into the block ACK processor, and this checks if everything is okay, if the response message is actually what we asked for, and if everything is okay, it adds those blocks to the block processor, which means they will be processed and added to the ledger. And at the same time, it calls reset last request to the candidate accounts, and that I think that makes that enables the priority requester to ask for more blocks for this account. So this is the priority request. Any questions, Nano fam? Any questions? Let me know. Fortune was no, just kidding, since I won 3 out of 5 spins so far. Yeah. Fortune says, is there a limit to how many blocks a node can request this way? Yeah, so it starts small. Let's have a look at the code. It starts, I think it starts with just 2. So you can initially just ask for 2 blocks for an account. Let's see. So where should we look at? Let's open up. Hey, it's birthday boy. Congratulations. Let's go to node, bootstrap, requesters priority. Pull count decider. I think this one. So as you can see, this is all, I think, just one class in the C++ node. I split that one up into many. So all of these requesters and response handlers are just one class, I think. And just so that I can write unit tests for that, I split that up. And there is this, I call them classes. I mean, Rust doesn't have classes. Let's say struct. So there's the struct pull count decider. I even wrote a comment, guys. I'm trying to write more comments now. Decides how many blocks to pull. And yeah, as you can see, the min pull count is 2. So it starts, I think it starts with 2 blocks. And if the higher the priority, the more blocks we pull. And the max blocks that we can pull are... what's the max blocks that we can pull? 128. So we cannot pull more than 128 blocks for an account at once. It's birthday boy says, receive the 1 nano. So cool. Okay, and is the delay okay? So did you first see the wheel and then you received the nano? Did you really add effects to move? Yeah, I added an effect here for the cursor because I thought it is easier for you to see where my cursor is going. So, see, there's this effect, and it's not just for you; it's also better for me because it's also easier for me to see where the cursor is at. It's birthday boy says, "Yep, takes 15 seconds." Yeah, so I guessed that the stream delay might be 15 seconds. So that's why the nano goes out after 15 seconds. But I can adjust that. And if now looks cool, yeah, it's better to track visually. Yeah, I like it a lot. So 15 blocks. No, what did I say? No, 128 blocks is the maximum, and 2 blocks is the minimum. And the higher the account priority, the more blocks we pull. Yeah, and there's more detail here, but we won't look at that right now, because we first want to understand the higher level concepts. And so also this diagram is a bit simplified because you can see the actual dependencies up here. So here you find those two. There is the priority requester here. There's the bootstrap state, and the bootstrap state has those candidate accounts. It has the running query container, and that is just a collection of all requests that we have right now. So whenever we send a request out, we put an entry into the running query container so that we know these are the outstanding requests. They haven't been answered yet. And whenever we receive something back, an acknowledgement, then we remove it from the running query container. And yeah, that one is called async tags in the C++ code. So async tags, I didn't know what that should mean, so I renamed it into running query container. Yeah, so let's go back to now. It says, please stop promoting surveillance tag. Surveillance tag? What do you mean with surveillance tag? Priority. So that was the priority bootstrap. And this is the heart of the bootstrap. And Bob said once to me, you wouldn't need any other methods if the candidate accounts was big enough that it could contain all accounts that we have. Of course it doesn't, so we throw out accounts from the candidate accounts, and that's why we have more here. So let's go to the blocking part. So blocking means we receive a block, and we can't add it to the ledger because it is a receive block and we don't have the corresponding send. Okay, so as you know, Nano has the block lattice structure where every receive requires a corresponding send block. If the corresponding send block is not there yet, we have a problem. So we can't bootstrap that account any further until we have the corresponding send. Does that make sense? Let's just, for the guys maybe that don't know Nano that well, let's just draw that quickly. So we have an account A and we have an account B, and account A does send one nano to account B. So that's a block from account A. So account B, if it wants to receive that nano, it has to create a block receive 1 nano. And that references the send. So this is the block lattice structure of Nano. And let's say we bootstrap account B and we come to this block. It says receive 1 nano, and we don't have that part yet. We don't have this block yet, the send block yet. That means the account B is blocked. And this blocking is handled in the dependency requester. So it all starts in a block processor. The block processor tries to add this receive block, and it notices that it can't do that because we don't have the corresponding send block. So it raises an event, a gap source. Gap source means the source is missing. The source block is missing. And it goes into the block inspector, which then calls block in the candidate accounts, and that just says, yeah, this account is blocked, and we store that information in the candidate accounts that this account is blocked. Later, on a different thread, the dependency requester says, hey, give me the next blocked account. So the dependency requester asks the candidate account, says, give me the next blocked. Congratulations, 1401. Give me the next blocked account, and then it creates a request for this blocked account. So it makes sense, yeah. So this account is blocked, so we have to bootstrap the source account first. So here again, account B is blocked. We have to bootstrap account A first. So this is what's happening here. So it says, yeah, give me next blocking, and then it sends an account request for this blocked for the source account. Then later we might get a response back with those blocks for that sending account, and this goes into the account ACK processor, which then says dependency update. Yeah. I missed something here, I think. Yeah. So this is actually a bit more complex, because let's say we have this one. So let's make it green. We have that block, and we don't have that block. This one is missing. So the only thing we know is that this block is missing. So this has a hash. Let's say it has a hash, ABBBCC, the block hash. So the only thing we know is that the the block with the hash AABBCCC is missing, but we don't know which account this belongs to, because the only thing we have is the block hash. Okay, so this is what's happening here. So we want to know what account does this block belong to, and that's what's happening here. Sorry guys, I think I explained the wrong thing initially. So the dependency requester says, hey other node, what account does the block with the hash AABBCCC belong to? And the other node from the network tells us, hey, this hash belongs to the account A. And then the account ACK processor calls back into the candidate accounts and says, hey, for this blocked account, I now know which account we have to bootstrap first to unblock it. And that's what this dependency update does. So it just tells the candidate accounts, what the source account is that we're looking for. And that gives that account priority. And then the next time the priority requester comes in, it might ask for that blocking account. MG says arrows backwards. Arrows backwards. Yeah, I think I'm with these arrows. I just meant the data flow. Up says, what is receive block is removed? Was there not talk of removing the receive blocks? There was talk about automatically receiving, so automatically generating receive blocks, because that is a safe thing to do. I don't know the details of that proposal. Should look into it. MG says you can't remove blocks. Once cemented, a block stays forever. That's true. Do you work for chain analysis? No, I don't. 41 says, isn't that lookup quite disk resource hungry? Looking up accounts only via hash of a block. It is not that resource hungry, because the only thing you need to load is the block, because the block contains the account. So it's the lookup of one account, one block. It's Birthday Boy says, so once we get a receive block that doesn't have its source send block yet, it gets paused until the send block's account is found correctly. Right. It gets paused until the send block's account is found, and we have bootstrapped the send block, the send account. Rams says, might have misunderstood, but would it not be simpler to just trace all transactions from the Genesis block? Basically, that's what we're doing here. So we start, that's also why it was called ascending bootstrap in the beginning. Now it's just called bootstrap. We start, so this priority only requests accounts that we have in the ledger. It doesn't request unknown accounts. So it starts with the Genesis account, and then naturally it will go into all the branches and bootstrap all accounts that are dependent on the Genesis account. So that was this blocking the dependency requester was all about. Finding out which account we need to bootstrap first before we can go on with the account that we originally wanted to bootstrap. And now let's go to the last part of Bootstrap, which is the frontier scan. Because with the priority and the blocking, the dependency requester and the priority requester. Yeah, it could be that we miss some accounts that we still need to bootstrap. So that's where the frontier scan comes in. And the frontier scan goes through it goes through all accounts that we have or that other nodes have. So this is not about our state. This is about nodes that we are connected to. So we ask nodes that we are connected to. We ask them, hey, what's your latest? Give me a list of all of your accounts and their latest blocks, and then we can compare this to our state, and then we can find out, oh, there's a block missing, there's an account missing. Yeah, and the way it is done is, so the frontier requester sends a frontier request. A frontier request, let's have a look at how the frontier request looks like. So the frontier request has a start. So accounts are sorted, not alphabetically, they are sorted by their representation as number. And then we can say the amount of accounts that I want to get. And what does this age do? What is age all about? Max age? What is age? I don't even know. It's not... That's strange. Yeah, so we ask other nodes, give us a list of your accounts and the latest blocks. Then we receive that, and the frontier ACK processor compares those frontiers. So frontier means, a frontier is a combination of an account number and a block hash. That's a frontier. Let's just add that here. So a frontier is an account number plus a block hash. And the block hash is the latest. So the latest block that a node has for a given account. So this is what we are requesting, a list of frontiers. The frontier ACK processor compares those frontiers to its own frontiers. This is done in the frontier checker struct. When it finds an account where our frontiers doesn't match the frontiers of other nodes, we increase the priority in the candidate accounts collection. So that means that our priority requester might request that account the next time. And I have a visualization for the frontier request because I debugged it and there was some issues. So I added the a visualization for the frontier scan to the RsNano GUI. So in case you don't know, RsNano does have a GUI mode. So let's run that. And let's have a look at how the frontier requests, the frontier scan works. I should have compiled this before the stream. So let's wait for the compiler. Its birthday boy says, all wins go into an RsNano pay faucet. Oh, cool. That's a good idea. How many wins? 12. So we sent out 12 nanos already. Oh, it's Birthday Boy. You got lucky. 3 nanos, 1 already. It's Birthday Boy says, when does the frontier check happen though? And how are the frontiers from peer nodes fetched? Is it requesting different accounts frontiers to different nodes in round-robin fashion? So it is asking different nodes. Let's start with the visualization because then it makes more sense. Should be done soon. Yeah, so the frontier scan, it sorts the accounts from smallest number to highest number. And that's the way they are stored in the database anyways. So it says start at account in the account range 0, all accounts that start with 0 to 1. And then it asks a node. It says, "Hey, give me a list of I don't know how many, 1,000, I think. Give me a list of 1,000 of your next 1,000 accounts sorted by their number with their latest block." And it does this in parallel, in 128 parallel executions. So finally, here we are. So this is the GUI for RsNano. And let's run a beta node. And then let's check the frontiers. So as you can see here, we are scanning does this? I hope this doesn't drop my internet connection like last time. So yeah, so it's scanning for frontiers, like 1,000. Yeah, this number goes down because now actual Bootstrap works, as you can see down here. So it's pulling 1,000 blocks a second. So that means we don't actually need to scan for frontiers. This adjusts. The frontier scan only starts scanning in full mode when we don't have enough blocks. But we do have enough blocks. As you can see, it's pulling 1,400 blocks a second. So that means the frontier scan is stopped right now. But what you can see here is the 128 parallel scans. So the first one scans accounts from 000 whatever to 02000, and the next frontier head scans from 2000 to 24000. So we have these 128 parallel scans going on, and they scan the full account range. And yeah, and we just ask random nodes we are connected to for a list of their latest frontiers. And then we compare them to ours, and so we can find out which accounts are out of date, where we need to pull more blocks. Yeah. And if Bootstrap wouldn't work so well right now, we would actually see those frontier scans advancing. See how many did it find? It found 1,623 outdated accounts, and that was enough now to get the priority requester to take the full bandwidth, and that makes the frontier scan stop. And only if the priority requester doesn't have any more to do, only then the frontier requester will start again. Isn't that cool? So that is it, guys. That is how Bootstrap currently works. Priority requesters, frontier requesters, and dependency requesters. And you can find all of that in the code here. So requesters, here we have the priority is its own folder because it has more like more parts to it. The frontier requesters here, and the dependency requesters here, and the state. All of that state that those requesters use are here. So here you have the frontier scan. For example, the frontier scan is managing those 128 parallel scan processes. And if you're interested in that, just browse through that code. And that is fully tested, by the way, so you can even read the tests to get an understanding of how that one works. Yeah. I hope that this explanation was a bit helpful. It's the first time I explained it, so it's probably not the best. But the next time I'll explain it, it will be better. I promise. Yeah, so how about we start coding now? Wenderson, are you here? Yeah, post your address, Wenderson. Nano is the light. It's supposed to be, what do you use to make these GUIs for both the Frontier Scanner and the Raffle? Pretty slick. It's a super cool Rust library called eGUI. And eGUI is this one here. So this is a Rust GUI library, and it's just a pleasure to work with. I like it so much because it's so super simple to create those GUIs. For example, that frontier scan page that looks pretty wild or pretty complex. It was just a couple of lines of code. So let me just show you like how few lines of code it is. So it's such a pleasure to work with it. Where's the tools? Inside GUI. Here, frontier scan. So this is. Oh no! Wait a second. Is this view? Frontier scan. That's the view model. Yeah, I combined. Okay, I combined the view model and the view. But the view part is just this one here. Just these couple of lines here. That's it. Just a couple of lines to create those 128 progress bars and stuff, and I can recommend it. Okay. Anderson, ich bin hier. You did an amazing job. Thank you. No, Paul, why are you trolling? I'm not doing a surveillance tech, man. Hey, Pies, welcome. Post your nano address and you can win some nanos. Norfell is a pro troll, yeah. Surveillance tech. Yeah, so let's start coding. And so what I'm currently trying to do is I want to write unit tests for the remaining bootstrap parts that are not tested. And I found out that you can create coverage reports super easily with cargo llvmconf, which is just this one-line command. It runs the tests and it gives you a nice HTML coverage report. So let's do that now, and let's see which parts of the bootstrap code is not covered by unit tests yet, And then let's try to write some tests for the uncovered parts. Yeah, pies. See your nano address, so you should be on the wheel for the next spin. Let's see. Where are you? Where are you? 10 participants. Why is your message not in here? That's strange. Oh. Oh, I have warnings. YouTube chat listener failed. Unauthorized. Let's restart it quickly. I can restart the spinner, it doesn't matter, because it's I also added that the participants list is saved into a file so that I can restart it. Here it is. And are you here? Yeah. Okay, that worked. Okay, interesting to see. So probably the auth token, gets dismissed like after 2 hours or 1 hour. I'm streaming for 1 hour. Ah, good to know. Good to know. So still some issues with this with the spinner wheel. Oh, I have to start again. Spinner is online. Okay. That was strange, but we noticed it. Okay. Okay. So just check again if you are you on the list, everybody? Are you on the list? 14 participants. If not, just let me know or post your nano address again. For the surveillance, of course, for the Russian hackers. So the coverage report is ready. So this is the coverage report, and let's scroll down to Bootstrap. Here we are. This is the Bootstrap folder. So the requesters, they look good. The response processors. This one doesn't look that good. The block ACK processor. Maybe we start with that. Block ACK processor. What is not tested here? Okay. Most of it isn't tested. Yeah, let's start here. So the block ACK processor isn't well tested. Process valid blocks. Okay, let's try to add some tests for it. Block ACK processor. Block ACK processor. And there is one test, response doesn't match query, and it tests that if the response doesn't match the query, we get a stats increase for invalid. So the stats, this is the thing that we can see in the Grafana dashboards. So this is just testing that if the response doesn't match the query, that it is not okay, so the processor returns false, so not okay, and that it increases this stats value here for bootstrap process blocks in and invalid blocks in. And then there's a second test that tests empty response. And it just tests, yeah, what that an empty response is okay. So yeah, that's okay. If we tell a node, hey, give us the next blocks, and the node gives us an empty response, it just means there are no next blocks. So that is okay. So these two tests we have already, and now let's see what is untested. Untested is this code path, where the verify blocks returns okay. So the verify blocks is that one. Where does it come from? Oh, this is in query verify blocks. So maybe we start there. Let's go to query verify blocks, because this has to be tested too. This is in state. Running query. Yeah, see, this isn't tested, right? My account, yeah, so this isn't tested. So maybe we should start there. Verifying a blocks ACK response. What does the comment say? Verifies whether the received response is valid. Returns invalid when received blocks do not correspond to requested hash account, or they do not make a valid chain. Nothing new when received response indicates that the account chain does not have more blocks. Okay, otherwise if all checks pass. Yeah, let's start here. We need to test this function, verify blocks, in the file running query. Running query. Error cases, verify frontiers. And maybe we can extract this into its own struct, but let's start here and then we can decide later. So just checking how this is structured. So let's add a mod, verify blocks. Oops. And Crafter says the music is a bit too loud today. Oh, good point, because I don't hear the music. Well, is it better now? Like that? Thanks for the tip. And Crafter says the delay could be set down to 10 seconds instead of 15. Okay, will do. 10 seconds, will do. So verify blocks. Let's call into verify blocks, and let's start here. The verify result is invalid if the query type is something else as blocks by account or blocks by hash. So we can start there. So let's start with invalid query type. So we have to create a running query, and we have to set the query type to something that is invalid for a blocks response, and that would be frontiers, for example. So we send out a frontiers request and we get a blocks response that is invalid. So let's try that. So this is only the query type is what matters in this test. So let's fill the remaining fields with test values. And then we call query.verifyBlocks. And we need a blocks response. So let's create that one. Blocks ag payload. Can I say new test instance? Yeah. And when we verify this response, it should return invalid. Bar. So assert that this result is equal to what's the type? Verify result. Verify result invalid. Okay. Or I want this test to fail. So let's just make an assertion that doesn't make sense. I want to, because this test will probably be succeed right away. So let's say nothing new, which doesn't make sense at all. And let's run those tests. No, Fel, I'm not gonna read your troll post, man. So, let's see. Ooh, why does the compilation take so long here? Okay, so yeah. So it fails for the right reason. It says it expected nothing new, but it was invalid. But actually invalid is the right thing. So now let's let's change the verify result to invalid. And that should make the test pass. And let's see what we have to test next. So that was the test for this code path with the invalid. Yeah, and did you hear that sound? Let's run test one more time. So when tests pass, it plays a sound. So that I know that the test passed, so I don't even have to look at them. So the next one is if blocks len is bigger than self count. What this line means is if we requested, let's say, 5 blocks and we got a response with 6 blocks, it's invalid because the node we talk to has to uphold our request. So if we ask for 5 blocks, it can't return more than 5. So let's write a test for that. Let's write a test for invalid block count, or too many blocks, or response contains too many blocks. So we say query type is blocks by hash, and we say count is 2. And now let's create a response with 3 blocks. So blocks payload blocks payload with, what does blocks payload have? Oh, nothing. Okay, it's just a vecdeck of blocks. Okay. So we can just say, is this? Oh, it has a new. Okay, so we can just say new, and then we can just say blocks. So we say blocks is a vecdeck is vecdeck new. and we just push 3 blocks into this. So let's say blocks dot push back. What does it contain? Just a block. So just block. Block. Why doesn't it suggest block? Oops. Import block. And as you can see, I have this new test instance function on probably all of my types. And this is a trick that I copied from James Shore, who has this these new test instance functions also for all of his types, because that makes writing tests so much easier if I don't have to fill in all of those details, because those details, they don't matter. For this test, I just need a list with 3 blocks, and it doesn't matter what those blocks contain. Pushback, sorry. Pushback. So it doesn't matter what those blocks contain. So it's nice that I can just say block new test instance, and I don't have to worry about all of those details. So now, the count is 2, the blocks are 3, and oh, you heard it, it is green already. So just making sure that this test is would actually fail if it would return something else. So let's just make sure the test works. Oh, that's taking way too long time. Too much time. Yeah, so the test works, so it should return invalid. Okay. So we got this one. What else? Blocks front, else nothing new. Yeah, let's add a test for this too. Why not? So if this response is empty, it should return nothing new. That should be very easy to write. So let's write a test that says nothing new. And that is just empty. And if that response is empty, it should say nothing new. But I want to hear the test fail first. Then I'm going to change it to nothing new and make it pass. Yeah, nothing new is the actual value, so nothing new will make it pass. Spinner wheel. Who gets the nano? Graptor. Congratulations. So we wrote a test for the nothing new case. And then we have this part here, and so these are 2 parts. So we can either request blocks by an account number, or we can request blocks by a hash number. By a starting hash, or by the hash of the first block that we want. So that's let's start by account. Let's go into this code path where invalid is returned if the blocks that we get are not for the account that we requested. So let's add a test for that. Let's add a test for that. So with the blocks we get are not for the account that we request. So we say blocks by account, and the account that we request is oh, I don't even need to do I have to set it? Yeah, let's set it because it's important. So I'm requesting account 1, but I'm receiving a block with a different account number. So how to do that? Test instance with key, test open. What does test open have? A different key, so this is definitely a different account. So when we run this test, oh, the name is wrong. So how can we name this test? Account. Received blocks is for another account. Or invalid when received block is for another account. So this is account 1. We push a block that is for a different account, and it should return invalid, right? Yeah. Yeah. So now let's just regenerate the coverage report. To switch to here. Another giveaway. And it's birthday boy. Congratulations for 1 nano. So, to refill my nano mug. So, cheers to you, Nano fam. Okay. So now let's reload that and see all of those red lines are gone. So we successfully tested this one. And if now nano mug merge incoming, one day there will be nano mugs. One day. So let's test the else part. So blocks by hash, and it should be invalid if the first block hash is not what we requested. That should be easy to do, to test. So let's copy that and let's say invalid when received block hash first received block hash is does not match request query. So we say the request type is blocks by hash, and then we say hash is block hash 1, and now we get a block, and this block doesn't have block hash 1, so this should return invalid. Oh, screen is gone. yeah, green. The next check is if the block length is 1. Okay, if you only get 1 block, it means there's nothing new, because we always request with the block that we already have. So let's say we have block ABC, then we say, hey, hey node, give me 5 blocks, the next 5 blocks starting at ABC. So we will receive the block that we already have as the first block in the response. So let's test that. So nothing new when response contains only 1 block. Blocks by hash. We have to make sure that that the requested hash matches. So let's just pull the block creation out. Just open test instance. Let's say block is a new test instance. And let's say the running query and the hash is our block hash. And then we return that same block in the response. And then the result should be nothing new. Congrats to me, says Underfnull. Norfell says Zcash is inherently more resistant to quantum attacks than blockchains that expose public keys, such as Nano. Okay. I don't know about quantum attacks. But okay. Yeah, those that quantum attack risk, that will be something that will affect a lot of projects in the future, I guess. Invalid, nothing new. Oh, it said invalid. It said invalid? Okay, maybe I made... Did I make a mistake there? Blocks by hash. Query type is blocks by hash. Hash is the... What else? Which check caused this to be invalid? Which check caused this to be invalid? The len, it can't be that. Oh, the account, it's not by account. So first hash is not start hash. Start. Oh, start. It has to be start, not hash. And what is start? Hash or account. So this is an hash. We have to convert the hash into a hash or account. Yeah, so the test was wrong. The test was wrong. This philosophy is flawed in all regards. No. Oh, come on, man. You know that's not true. Okay, so the test is green. Nothing new. Okay, when response only contains 1 block. So Cruptor asks, is Rust ready for V28? It is. So we are behind just a couple of commits, 19 commits behind, and I'm going to merge them this week, next week, I don't know. Those things are not hard to merge, like no huge pull requests really. So we are almost up to par with the C++ code, and bootstrapping works and voting works. So yeah, I'm just waiting for the C++ node to release V28, and And then very shortly after, I want to release the RsNano 1.0 version. So I think like maybe a week after V28 is ready, RsNano will be ready. That's my guess. 1 week. And if not says, I think we will have totally different problems if quantum computers could break currently used cryptography. Yeah, it would break everything, like online banking, everything. And we can upgrade Nano's cryptography algorithms. It's not easy, but it can be done. Which probably would mean that you would have to create new accounts. But yeah, there's a way to counter that, and it's not only Nano. It's probably most of most crypto projects. Copter says, will it be safe to run Rust node? Will it be recommended, or will there be a beta testing first? It will not be recommended because it's 100,000 lines of code that hasn't run in the live network yet. So you should expect bugs. So it is not recommended to run it, but I will release it anyways for people to test it, and I will switch my principal rep to the Rust node probably as the first principal rep that runs on Rust. But I think we should slowly and carefully encourage people to run the Rust node slowly, so that if there is any issues, we can fix them, and it shouldn't affect the network. And beta test, you can beta test it right now. So you can build your own Docker image or compile it easily and run it. And I've been running a beta node for 2 weeks or 3 weeks now, and found some minor issues and fixed them already. But it's looking good. Looking good. That will be exciting. The first Rust node in the live network. So which test did I want to write? So I wanted to say this one we just wrote, right? Tester green, tester green. So now verify blocks, make a valid chain. So what does this test? Okay, so that it is a valid chain means that for every block we get, the previous block is actually the previous block in our list. Okay, let's write a test for that. Cool. Let's copy this. Invalid when response blocks are not a chain. How can we do that? So maybe just pushing the same block twice. Like that. Oh, I forgot parentheses. Block. Oh, I have to clone it because it got moved. Okay, green. But I'm not sure if this actually tested the that line that I wanted to test. So let's just run the coverage tool again and see if this line is now covered. And while this runs, the only missing part is the okay case, so the happy path. Okay, let's write a test for the happy path while this coverage tool runs in the background. And I want to put the happy path on the top of the tests because that's what I usually do. So these are all the error cases. Let's say happy path. And for that we need to we have to say blocks by hash, by count, by count. By hash, by count. Doesn't matter. We need 2 blocks. How do we do that? We need 2 blocks. Test instance. I think I have a builder that I can use. Test block builder. Right? Yeah. State block. And so let's call this block 1. And now let's create a block 2. And that block 2 has as previous block 1 hash. Is this enough? Let's try. We say blocks by hash. Start is block 1 hash. The response is contains block 1 and block 2. And this should be valid. Congratulations, Wendelson. 1 nano. Ah, there's still a line not covered. Okay. But let's run these tests now. Oh. Hash or count into converted into hash or count. Crafter says I don't like this song. Me neither, you're right. I was in such a hurry and I just started whatever. Let's pick something else. So green is good. So now I think we should have everything covered, right? Oh no, this one wasn't covered. The previous hash is block hash. This is the chain thing. Why wasn't this line executed? Ah, okay, because for this line we need 3 blocks. Because if the blocks contains 2 and it skips the first, it will only go into this comparison and immediately say it's invalid. So we have to change the test to contain 3 blocks. Difficult at first, it's loud for you now. You don't like the song Cropter. No, I like that feedback because I can't hear if the music is too loud. And honestly, I don't like the music that much either. But I have to be careful which music I play because of the copyright. And that is all. This is all royalty-free music. So what this test is, it was a depressing song, yeah. It was the chain. Invalid response when blocks are not a chain. So we have to push another block in there. Okay, so we have to do this differently. So we have to copy our blocks from the happy path. Like this. So block 3, and block 3 will have an invalid previous block. Like this. So this is now not a chain. And the start is block 1. And now we add 3 blocks. So this should fix it. And then let's commit. Let's commit this, and then, yeah, let's see what else needs to be tested. $14.01, congratulations. Just one nano. What does the chat say? Norfell says, I can see your balance of 1,700 nano. Imagine RsNano goes to $420. Huge security risks to oneself. Yeah. Well, but that's the same in Bitcoin, more or less. Okay, the UTXO model is a bit more anonymous, of course, but yeah, that's just the way how an open blockchain works. What was that? Okay, see, everything covered. No, not everything. This one has a 0. What is this? By account. So if, okay, this is the happy path by account. Says we did not cover that. Yeah, let's do that. We wanna have a full coverage here. So let's quickly add a happy path for requesting by account. So this is for requesting by hash. So let's add a test. Happy path by account. And happy path by account. So this is blocks by account. And here we say account is block1.account field into, and we got that. Let's see if that passes, and that should give us the 100% coverage of that function. Oh, it failed. Invalid. Probably the test is not right. Probably the test is not right. What about... What about the account? Okay. Verify blocks. Start. So start. Oh, not account. Again, start. Same mistake. So if you're interested what a running query looks like, so the running query is the data about a running query. So it has a unique, it's a test pass, a unique ID. The source says which requester created this query. The query type, as you see, is like blocks by hash, frontiers, and here, this is the query type, blocks by hash, account info by hash. The start is either a hash if we request blocks by hash, or it is an account if we request blocks by account, for example. And the account is for which account this is. So we need this to limit queries for an account, for example. The hash is for, if this is for a certain hash, the count is how many blocks to pull, I think. And yeah, sent is the timestamp when it was sent. It's birthday boy, congratulations. And the response cutoff is when this query times out. So if we reach the response cutoff, this query is dropped. And if we receive a response to this query after the cutoff, the response is just ignored. Okay, everything is green. Let's commit this. So add unit tests for what was the function name? Verify blocks. And push it. Crypto says, I guess it would be possible to mix it, maybe trade it all to Monero and then swap from Monero back to Nano. Yeah, that's it. I mean, there are ways to get some anonymity. You could also send it to an exchange and then from the exchange to a new wallet. So yeah. I mean, I would love if Nano had a Monero-like privacy, but as I said, I have not seen any proposal that wouldn't introduce other downsides that I wouldn't want to have in Nano. So yeah, what does Norfell say? Nano should be advertised as non-private digital money. Otherwise, advocates could face criminal charges, false advertisements opposed to Russian hackers. What's up with you Russian hackers? Yeah, and as others have said, like if Nano was had Monero-like privacy, it would probably be forbidden, banned by governments. So yeah, so we pushed that. We increased the test coverage a bit. And how many nanos do we have left in the wallet? Only 4. And oh, okay, it's already late. So I don't want to start a new task. So let's maybe end the stream. If you have any questions or anything to say, I don't want to start a new test part here because it's late already. And yeah, Corruptor says Grandma will probably use custodial services. Oh, what now? Says good luck teaching Grandma to mix her clean monies with criminals. Yeah. I mean that's also why we have multiple currencies, cryptocurrencies. We have privacy-focused cryptocurrencies, and we have payment-focused cryptocurrencies like Nano. And I think there's a place for both. I don't think there should be only one currency to rule them all, because you can't be the best in in all categories really. So Nano focuses on speed, so low latency, feelers, eco-friendly. These are the 3 priorities that Nano has. And it's okay that there are other currencies that focus on privacy, but they, on the other hand, they don't have a feelers protocol, and they are not instant and as well suitable for payments as Nano is. So Nano is a payment coin, and that's okay. And it's okay that there are privacy coins, and they can coexist. They should coexist. Underflow says, how do you plan to do the versioning of the Rust node? For example, backward incompatible changes. Yeah, I thought about that, and initially I thought I would just stick with the C++ version numbers, and then I thought, no, that is a bad idea, because I don't want to couple my project to the C++ code. Imagine if I used the same version numbers that I could only release if the C++ node releases a new version, and that would be stupid. Like really, like I don't want to couple my project to the C++ project. So that's why RsNano will start with the version 1. And because like even if I started with version 28, they would eventually decouple, because my release cycle is different from the C++ node. So they would decouple anyways, or like diverge, not decouple. They would diverge anyways. So I'm starting with version 1, and that makes it very clear from the beginning that RsNano's versioning has nothing to do with the C++ versioning. And if not, I'm asking for a situation if C++ codebase has like v28.1.14 version and you need to release a new backward incompatible version. Yeah. But we have to keep in mind that there is 2 versions. So there is the version number of RsNano, and then there is the protocol version. And the protocol version is the important one. So RsNano will have the same protocol version as the C++ node. And of course, because that defines which protocol it uses. And the version number for RsNano itself, it doesn't really matter. Wonderful. Is there something like a nano protocol versioning? There is. So there is protocol info. So when we send messages, the message contains the protocol info, which is version using. It means the version of my node, the network version, which is currently hexadecimal 15. What is that in decimal? This is the current version, network version. So my nodes, whenever my node, the Rust node communicates with another node, it sends its current network version, it sends the maximum supported network version and the minimum supported network version. This is in the message header of every message. And the network. And this is the important version. And here we can, with this version, we can see if there are incompatibilities between the nodes. Yeah, so this is the nano protocol versioning. And RsNano will have version 1.0. Thanks, so it's a v21 network. Yeah. Yeah, and when there are new network messages, we have to increase the network version. I think the last time it was done was the ascending bootstrap messages that got added. I think that was the last time the network version got increased. Okay, guys. So 2 nanos left. I'm just adding them to the next stream when we stream again, and maybe next stream we will try to mob program. I want to see if I can prepare that here so that you can join. I would use Visual Studio Code live share for this, and give you a link so that you can connect your webcam to my stream, and let's see if that is how that goes as an experiment. All right, it was nice seeing you all again, and see you all next week on Tuesday. Have a good night. See you then.